To recap, today we looked at the connection between the link layer and the physical layer and how our link level frames get encoded in that physical media. Often that involves negotiating a shared medium, and so we had two main ways to share: time division multiplexing and frequency division multiplexing, and various ways to allocate those divisions. Polling, where a leader asks the other nodes whether they have something to say. Token passing, where each node has the right to communicate or not, and then passes that on to the next one. Or random access, where everyone just tries to use the medium, and then you need some way of detecting collisions or detecting that someone else was talking and recovering from that with retries. And with that, we're done with our investigation of networking layers. We started at the application layer and worked our way all the way down to the link layer and towards the physical layer. We'll leave the physical layer itself to the electrical engineers and physicists, because mostly as we build systems, we're up here at the application level, and we get to take advantage of the abstraction at that level and not worry about the lower levels. Considering that, you may even feel that it was unnecessary to go all the way down like we did. But in the context of network security, a lot of attacks are based on the idea of breaking an abstraction that turns out to be a little bit leaky to the upper layers, breaking it down at the lower layers. So an appreciation of all these different layers helps you understand what is possible and how upper layers of abstraction might need to compensate, after all, for a leaky lower layer of abstraction.